Hi everybody, this is Math 024, Module 5, Video 1, and in Module 5 we are going to look at systems of linear equations. So we're going to have two variables and two equations in our systems, and that's what a system of linear equations is. It has two linear equations and two different variables. So, up until now when we've solved equations, we've had one variable such as x or y, or it's been equal to y, like if we're graphing it, we've used two. But when we solve to find like a solution, we've only looked at one individual variable. So now we're going to learn how to solve a system and find the solution. And the solution to a system is not going to be a single value, but it's going to be an ordered pair. So it's going to be, written just like we would graph in that XY format. So it's going to be written in ordered pair format. And of course, that first value is for X, the second value is for Y. And most of the time, that's all we're going to do is X and Y. Sometimes we'll have different variables, but it'll still be written in this format as an ordered pair. The first thing we're going to do is, you can see here, we just have a couple systems, and they ask, is this ordered pair a solution to the system? And in order for it to be a solution, when you substitute in your X and your Y value, they have to work with both equations in order for it to be a solution. So, to check this out, to see, I'm going to look at this first equation. So we have 2x, and instead of x, I'm going to put a -2 minus 3 times -4. And we're going to see, does that equal 8? And so 2 times -2 is -4 minus 3 times -4 is a -12. And again, we'll do addition of the opposite there. So -4 plus 12 does equal 8. So it works for the first equation. Let's try the next one. So it's -2 minus 2 times -4. We're going to see if that equals 6. Negative, we can do, I'm going to make this plus a negative, make life easier. Two negatives make that a positive. So -2 plus +8 equals a +6. So it works for both equations. When you substitute in the x and the y value of this ordered pair, -2, -4, it makes the equation true for both. So yes, it is a solution for A. Let's take a look at B. Now our x is 12 and our y is -8. So I am going to do 4 times 12 plus 3 times -8. And we're going to see, does it equal 24? So we really got to make sure are both sides the same. 4 times 12 is 48, plus 3 times -8 is -24. And then we want to see, again, does it equal 24? And here, 48 plus -24 will give me 24, and that is equal to 24. So it does work for the first equation, but you always have to check both. So let's look at the second equation, and I'm going to do 3 times 12 plus 4 times -8, and we're going to see, does it equal a -4? So really, that's our question. Are they both the same on both sides? 3 times 12 is 36, plus 4 times -8 is -32. And we want to know, again, put our question mark there, does it equal -4? I know 36 plus -32, that's going to be a 4. And 4 does not equal -4. So this ordered pair worked for one of our problems, but not the other. It has to work for both in order to be a solution to the system. So this is not a solution. All right, so when we are solving systems, we are going to look at 3 different ways to solve systems. The way we're going to look on this video is we're going to look at graphing. And then on the next video, we'll look at using substitution and elimination, or the addition method, to solve systems. So when we solve a system by graphing, remember, their solution is going to be an ordered pair. So what we're going to do when we solve by graphing is we're going to graph both lines on the same coordinate plane or the coordinate axis. And if their intersection exists, if the two lines meet at a point or cross at a single point, then we'll list that as the solution to the system. Sometimes, though, you're going to have parallel lines, so they would never meet and they would never have a solution. Or sometimes we're going to have the equations, even though they don't look the same, they are exactly the same lines. So really any ordered pair on the lines would make a solution. And we'll take a look at a couple of those as we graph, so you can kind of see what that means. And graphing is probably the least accurate way to look at the solution. It's really if you want an estimate, because, graphing, when we're drawing those lines, you've seen my lines on my graphs, they're not always perfect. And then also, it's not going to always land on perfect whole numbers, so you're going to kind of estimate that ordered pair. So again, it's not going to be perfect when you graph. If you want an exact solution, you definitely want to use substitution or elimination. But if you need an approximate solution, graphing is the way to go. All right, we are going to graph these two systems or find the solution to the systems by graphing them. So we're going to start with A, and we're going to graph this system, x plus y equals 2, and 3x minus y equals negative 2. So I'm going to create a t-chart for both equations, and I'm going to write it over here off to the side, so I'll just have to erase it for the next equation. So I'm going to create a t-chart for x plus y equals 2. And again, they don't give us any values. You pick a value for either x or y and then find the other one. So if I plug in a 0 for x, that means I'm going to have 0 plus y equals 2. And then we can see there that y would have to be 2. Let's plug in a 1 for x. If it's 1 plus y equals 2, then when we solve it, y is going to equal a 1. And then let's just do, so you can see using both ways, let's pick a 0 for y. So if I make y 0, then I know that x is going to equal 2. So now I have enough points where I can graph that line. So let me do that. I'm going to make it blue so we can see it. So I'm going to graph, I have 0, 2, which is right here, 1, 1, which is right there, and then 2, 0. All right, so here is my equation x plus y equals 2 graphed. Now let's look at the 3x minus y equals negative 2. So again, we're graphing now 3x minus y equals negative 2. And I'm going to make a t-chart here. So I'm going to start off, I'll plug in, let's just plug in 0 for x. I think that makes it easier. So if we do 3 times 0 minus y equals negative 2, that gives me 3 times 0 is 0. So now I have this. I have the opposite of y is equal to negative 2. Or think, there's like that negative 1 there. So what I'm going to do is divide by negative 1 here, and y is going to equal 2. Let's see, if I plug in, let's do a 1 for x. So 3 times 1 minus y equals negative 2. 3 times 1 is 3 minus y equals negative 2. So we're going to subtract 3 from both sides. So I have the opposite of y, or negative y, equals a negative 5. So again, divide by that negative 1, and y is going to equal 5. And then we could put in another value, like we could do, kind of running out of space here, I didn't plan this out very well. Let's put in a negative 1 for x. So if I do 3 times negative 1 minus y equals negative 2, that gives me negative 3 minus y equals negative 2. So I'll add 3 to both sides, and I get, I'm going to switch to red so you can see it, the opposite of y is equal to 1. And then again, divide by that negative 1 there. So y equals a negative 1. All right, let's graph this line. So I have 0, 2, which is right here. 1, 5, which is right there, and -1, -1, which is right there. So then I can draw my line. And as you can see, the solution to the system is where the two lines meet, where they cross. So in this case, and on this graph, it's kind of easy to see, the solution to the system, the answer is 0, 2. That's where the two lines meet and where they cross. So that will be our answer there. Now what I am going to do is I am going to erase a little bit so that I have space to put our t-charts in for the second one. I'll leave the solution and the equations up there, the graphed ones, but I'm going to erase the work. If you need to review, go back in the video and review before I erase it all. Okay, so now it is all erased. Okay, so now let's look at B. We're going to graph this equation, and our first equation is going to be 2x plus 2y equals -6. And again, I'll make a t-chart. And I'm going to try to just do like 2 ordered pairs. You can graph a line with 2. I usually say try 3 for like insurance purposes to make sure you're doing it right. But for now, we're gonna do 2. And with this one, I'm going to plug in a 0 for x because I like to put those zeros in. I think it's a little bit easier. So that's going to give me, 2 times 0 plus 2y equals -6. Anything times 0 is 0. So remember, this is really going to drop off. And we're going to have 2y is equal to -6. And when we divide by 2, we're going to end up with y equals a -3. And then let's do the same thing, but put a 0 in for y. So this is what we call graphing by intercepts. So we have 2x plus 2 times 0 equals -6. Draw a line there. So again, this equals a 0. It cancels out. So we have 2x equals -6. Divide by 2. So x is going to equal, again, a -3. So when I go to graph this line, my 2 ordered pairs are 0, -3, which is right there, and -3, 0, which would be right there. So here is my first line. And again, I don't know why the pen never makes it straight, but all right. And then our second one that we're going to graph is x plus y equals 1. So this one's nice and easy. Add a 0 in for x. And y will be 1, add a 0 in for y, and x will be 1. So let's graph. We're going to do 0, 1 right here, and then 1, 0. And then I'll draw my line. All right, now the solution to this system is where the two lines cross. But if you look at this graph here, you're going to see that these appear to, and again, my lines are a little wiggly, but if you graph it better on your paper, these are actually going to be parallel lines. So because they are parallel lines, there is no solution. The lines will never cross. So we have, again, our graph shows us parallel lines. So the system has no solution because they never cross, so they can never share an ordered pair for a solution to the system. So there is no solution. All right, now we're going to graph our last equation here, or system, I should say. So let's look at our ordered pairs that we're going to make. So our first equation is x minus 2y equals -6. So again, I'm going to make a t-chart. I'm going to plug in a 0 for x because it makes it easier. So if I do 0 minus 2y equals -6, that means I'm going to have -2y equals -6. Divide by -2. So y equals a 3. And then let's make life easy again. Let's plug in a 0 for y. So then we'll have x minus 2 times 0 equals -6. But again, that 2 times 0 is 0. So x equals a -6. So And we have 0, 3, and negative 6, 0. And then let's take a look at our second equation. So we have negative 2x plus 4y equals 12. All right, and let me go back and I'll graph this real quick. So we have 0, 3, which is right there, and negative 6, 0. So here's our first equation graphed. Okay, now let's go back to our t-chart for the other one. All right, let's again do a 0 for x. So if I do negative 2 times 0, plus 4y equals 12, that's going to give us, again, that'll equal 0, so we have 4y equals 12, divide by 4, so y is going to be 3. So we'll put our 3 in there. Let me make a little bit more room. Let me erase this real quick. All right, next, let's put a 0 in for y. So we're going to put a 0 in for y, so we'll have negative 2x plus 4 times 0 equals 12. And that, again, 4 times 0 is 0, so we don't need it. Negative 2x equals 12, divide by negative 2. So x is going to equal a negative 6. Interesting. If you look at our ordered pairs from here to here, they're exactly the same. So when I graph this line, when I graph the second equation, it's going to be the same points. So for this problem, because our points are exactly the same, both of these equations are the same equation. It's just written in a different format. So because it's the same line, and you only get one line, then that means that because the two equations are exactly the same, there is an infinite number of solutions to this equation, because any solution that works for the first equation will work for the second equation. So for this one, there's an infinite number of solutions. So you would just have to say, there's an infinite number of solutions to the system because they're exactly the same. All right, and the last thing we're going to talk about are just the types of solutions to a system. So we are going to talk about if this system is consistent or inconsistent. If it is consistent, it means that it has one or more solutions. So it could be, one solution like we saw in graph A, or more solutions like we saw in graph C, where every solution or every spot on that line was a solution because they were the same equation. Inconsistent is a system with no solutions. So think B, when we graphed B, we had parallel lines. That would be inconsistent. Now, to go along with that, we're going to call it inconsistent or consistent, and then dependent or independent. So if it's dependent, it's the system with infinite solutions. So it's going to have the same line, so it's going to have one line graphed on there, and that's it. Independent means you have one or zero solutions. So really independent, think you have two separate lines. So it could be lines that meet at a point or parallel lines. So if we look here at our graph of x plus 2 equals y and negative x plus y equals 3, they've graphed it for us. We have, it looks like one solution where the two lines cross. So that is going to make it consistent because it has one solution. And then because we have two separate lines, it's going to make it independent. So we have different lines, so it's independent. All right, for B, let's see. We have two lines, but here you can look, they never crossed, they never made it a point. So there's no solution because it's parallel lines. So we are going to call it inconsistent because there's no solution. But it's still independent because there are two different lines. So it's inconsistent, but still independent. Okay, so now for C, if we look here, we have one single line there. So that means they're going to have one or more solutions because everywhere on that line is going to be a solution. So it's going to be consistent, but because there's only one line, it's going to be dependent. And then here we have two separate lines. And if we look, and if we were to like extend this out, they would eventually cross and meet at a point. So it is one or more solutions. So it is consistent. It's not parallel lines, but it's independent because there's two separate lines. And that is it for our first video. In our next video, we will look at the other two ways of solving, which will be through substitution and elimination.